So here controller component runs a controller process that regulate the state of the cluster. So each service, so if you want to replicate multiple pods, yeah, while using deployment resource, so automatically the backend this controller will replicate this controller, such as runs controller processes. So here endpoint controllers, namespace controller, like that each and every component backend. So when you go to fire one command, this one, so kubectl get pods hyphen n cube hyphen system. So this is a Kubernetes cluster namespace. So in this namespace, all Kubernetes component backend components created. So after creating cluster, you can see by using that command. So next etcd component. So API is our scheduler is our controller component is etcd. So here etcd consists a high availability key value store used to Kubernetes. So baking store all cluster data. So high availability means if you do any external volume mounting, so these kind of activities, so by using these key value pairs, it can store the data in the cluster environment. It is saying like that. So these are all components about master node. So now coming to worker nodes. So worker node components, kubelet and optional add-ons, network proxy, and container runtime. So container runtime already, when you install Kubernetes, kubectl and ekctl, automatically Docker also installed. That is the container runtime. So next, node components, kubelet. The primary node agent that runs on each node and ensure that containers are running in a pod. So it is clearly saying the primary node agent. So these are the primary, these are the one, take one, this node as a primary agent node. So the primary agent node that runs on each node ensure that containers are running in a pod. So that specific node, it is going to assign pod. That is saying that is a kubelet responsibility. So here kube proxy. Now coming to kube proxy. So maintain network rules on nodes. So what are the policies you are providing in the AWS or Azure or GCP? It doesn't matter wherever you installed Kubernetes cluster. So backend network rules assigned. So node manager nodes and worker nodes, group policies. These kind of network policies, this group proxy will handle. So forwarding traffic to appropriate container based on IP and port numbers. So this is these use cases take care about group proxy, container runtime. So container runtime already know. Currently we are using Docker. So if it is Red Hat means Docker Podman. So Docker kit, a lot of you can search in Google what are the container technology for image building. You need to find top 10 tools. So we'll get all tool names. So one of the best popular tool is a Docker. So everyone is working Docker. It is a Cryo, Mesos, like that. Other container technology tools also there. So if your organization uses Cryo or something else, so you need to work on based on which syntax you need to follow and understanding the components. Then you can easily work on any tool, not only specific Docker. So here coming to add-on. These are the add-ons, optional add-ons like UA, DNS. So coming to DNS, provides DNS-based service discovery for Kubernetes services. Means it is generating node port and cluster IP and load balancer. So these all are coming to DNS components. So it is take care about add-ons. So dashboard. This is the UA. If you want to see each and every component after deploying applications like a number of pods, services, deployments, stateful sets, so volumes, you can see in this dashboard. So so there is an interface you can install by using Helm chart. So I will provide that after completion of Kubernetes. So I will share so currently we are using any company using external tools like Grafana, Prometheus. So like ELK stack, but this is the default dashboard also there. This is the in-house tool for Kubernetes dashboard. So you can install dashboard and check out the all components there itself. So coming to Ingress controller. So Ingress controller manages external access to the services in the Kubernetes cluster, typically through HTTP, HTTPS. So if you want to assign any specific domain to this cluster services, if you want to access externally, you can use Ingress controller. So we'll discuss these components practically. So next, heat star. So collects the and interprets various metrics from the cluster and pods. So heat star is these all are add-ons, remember. So backend components. Heat star is the collecting metrics and CPU metrics and memory metrics, this type of metrics and pods related, node related metrics, all captured by heat star. So cluster autoscaler. So Kubernetes is also providing autoscaling features based on load. It is automatically increasing pods and down the loads. If load is workload is down, then automatically pods are automatically down. So if workload is getting user load is more, then pods are automatically increased. So these kind of features this Kubernetes cluster providing. This is the cluster autoscaler. This is also comes under add-on component. So networking. So here talking about view proxy already we discussed. So these are all components about Kubernetes architecture. So you can explain like this only, more than enough. So interval feel that he has good knowledge about cluster and components. Definitely interval feel like that. So here coming to networking. So pod networking enables communicate between pod across nodes in the cluster. So how will happen? So we'll discuss while while deploying use cases, pods and deployment and service resource. So while discussing service, Kubernetes service, we have multiple modes. So cluster IP, node port and load balancer. How will these pods communicating in the cluster environment? You can understand how these are enabled backend diagrammatically. I will explain. So enable communication between different parts of an application. So pods networking means enable communication between pods across nodes. So all here you, you can take one service, means one module cart. So if you replicate 100 pods means, so 100 pods will create randomly. So whichever node we don't know. Cluster will take care about that. So but in that case, each and every pod creating different nodes. So how we enable to communicate these pods? This is the pod networking. So you will understand after discussing about service. So next, network policies. Network policy, how you how will you manage secure communication between pods? So you need to do hands-on these kind of activities also. This is all about Kubernetes components, architecture components, and table of content. What is Kubernetes? And Kubernetes and adoption in the enterprise and companies. Why are so these kind of questions you will face. So so you need to explain benefits about these kind of questions. So you need to differentiate a Docker Swarm in this case. So some some of the orchestration tools are also there, but compared to Kubernetes, there are lack. You can say like that. So a lot of drawbacks. You can differentiate like that. Then good. So next, architecture already discussed it components. So this is also covered in the interview question. So what does the controller pane go with all this? And Kubernetes concepts, tools, deployments, other important elements. And finally, conclusion. Finally, we'll discuss mock interviews. This is all about Kubernetes course. So coming to what Kubernetes can do. See here, provides tool for app deployment. This is the tool. So we can deploy containerized applications or microservices based applications in the form of containers by using this tool. So this is the one key component, the key feature. So second is a scaling based on load. Already we discussed based on load up and down. So automatically scale up and scale down. One thing we need to do so manually you can up the nodes only. Nodes you can up based on load. So pods we cannot. Pods will take care about the cluster. Kubernetes cluster take care of. So here managing cluster of containers. How cluster is managing containers. So this is the one feature. So help to optimize use underlying hardware and found below the your containers. So how will managing this Kubernetes cluster and each and every service, how the managing underlying sharing the resource, hardware resources and everything by using by deploying use cases you can understand. So change management means version upgrading and patching the lot of things. This is also best feature. Enable app components to so it can restart and move through the system when as needed. So self-healing mechanism. So these all are features. So Kubernetes benefits. So scalability, high availability, portability, security. So here I mentioned, so already scalable. We discussed based on load, up and down the load, up and down the pods. So automatically Kubernetes will take care about these things. So high availability means you can take the backup data externally. So and deploying same application in multiple regions and mounting data in multiple regions and replication also supporting. So for that you need to install external drivers for high availability components. So portability. Coming to portability, Kubernetes is designed for various choice of operating systems, container runtime, cloud platforms, PaaS, platform as a service. Kubernetes comes under platform as a service. So process architecture, so you can configure Kubernetes cluster on different Linux distributions like CentOS, Debian, Fedora, or CoreOS, Ubuntu, Red Hat. So many flavors are there. You can set up this Kubernetes cluster environment. So this is the portability. It is not dependency like a specific OS. So that is saying clearly. So you can deploy it in run in local and virtual environment based on KVM and library. So and vSphere. So some of the additional components are there, virtual environment. So serverless architecture for Kubernetes is capable running on cloud platforms like Google and Azure AWS. These are the major clouds. Some other clouds also popular like Oracle Cloud, IBM Cloud, and DigitalOcean. So mostly focus, my side suggestion is AWS and Azure enough. So if you know about Google services, then you could be very strong in any one of compared to anyone. So focus on these cloud is enough, Azure and AWS. You can also create hybrid cloud if you max and match cluster across cloud providers on on-premises. So on-premises means it's an unmanaged Kubernetes. So we can use COPS and COPS setup for unmanaged and means on-premises. So local environment. So if any organization managing servers in the local limits, that is comes under on-prem. Off-prem means these are the clouds, Google Cloud and Azure, AWS. These are the off-prem. Who can set up cluster environment on-prem or off-prem. So these are the portabilities. That's why he's saying portability. And security means we can use Istio and other external tools for us communicating, secure communication for application. So you can do those kind of activities by using Istio. Some of the tools also there we'll discuss as a part of daily sessions. Next, advantages, automatic bin packing, so load balancing and service discovery, and storage orchestration, self-healing, secrets and configuration management, and batch execution means so this is the version upgrading. Horizontal auto scaling means automatic horizontal scaling means this feature is a very any compared to any tool orchestration tool, this feature is not available. Kubernetes, that's why very popular. So automatic rollbacks and rollouts. These are the highlights of about Kubernetes. So I will share these all components. So next, okay. You have any doubts, you can ask till here. Hello, Vamsi. Hello, Ramay garu.
అవి సింపుల్ గా అలా చెప్తే సరిపోతుంది. కుబర్నెటిస్
చెప్పండి, ఉన్నాను నేను. పరశురామ్ గారు.
అదే మీకు ఏమైనా డౌట్స్ ఉంటే క్లియర్ గా అడగండి అంటున్నా.
సరే సరే.
సో వంశీ,
ఆ,
అంటే ఇట్లా చెప్తే మోర్ దాన్ ఎనఫ్. మన క్లస్టర్, మనం కుబర్నెటిస్ ఏం డిజైన్ చేయం కదా, జస్ట్ ఏంటంటే ఆ కాంపోనెంట్స్ ఎట్లా వర్క్ అవుతున్నాయో తెలిస్తే చాలు. అంటే నువ్వు హ్యాండ్స్ ఆన్ నువ్వు కాంపోనెంట్స్ అన్ని నువ్వు పిక్ చేసుకోగలవని వాళ్ళకి ఒక కాన్ఫిడెన్స్ వస్తుంది అన్నమాట. సో అది బిల్డ్ చేస్తే చాలు ఇక్కడ మనకి అట్లా. సో నెక్స్ట్ ఇంకేమేమి డిస్కస్ చేస్తామంటే, మనం కాంపోనెంట్స్ అంటే ఫస్ట్ కుబర్నెటిస్ ఇన్స్టాలేషన్ సెటప్ డిస్కస్ చేసుకుందాం. Visible, right? Okay. First, you need to, currently we are working with AWS, right? AWS services. So there is a in-house tool called EKS, Elastic Kubernetes Services. So first step, cluster setup. Create instance, EC2 instance. So we can take Ubuntu or Amazon Linux. Red Hat also possible, but creating, so initially you need to understand first open source Ubuntu servers. It is a better. So after that, we need to work on Red Hat. So organizations, definitely 70% of the companies using Red Hat flavor. So you need to work on Red Hat flavor. But finally, end of the session, I will deploy this Kubernetes cluster in the Red Hat OS. So I will share the each and every component installation steps. But here, create Ubuntu instance. Ubuntu operating system. First step. Second, need to install kubectl. Install ekctl. Next step, you need to set authentication permission for cluster access. See here, EC2 is a one API service in AWS cloud. Same like EKS, another API service. If you want to communicate one API to another API, you need to attach role and give those permissions. Then only these components will communicate. Otherwise, things will not work. For that, we need to use IAM authentication or provide access key or secret access key. So we need to create one specific user and create access key and a secret access key for that user. And just you need to install AWS CLI. Next step. Then fire one command. AWS configure. Then immediately it is asking command line. So access key and secret access key and region. So if you want to choose specific region, you can deploy a Kubernetes cluster that specific region. So this is the setup for Kubernetes initial things. After finally, default region, default file format. Next, finally, fire one command. ekctl create cluster. Hyphen name. So provide cluster name. So prod. So region. US West 1. You can find the AWS console, EC2 console. So all regions are visible. So this is the North California region that I have mentioned, US West 1. If it is Mumbai means AP South 1. If it is Hyderabad means AP South 2. Hyphen nodes. How many nodes you want to create? These are the worker nodes. Hyphen node type. What type of hardware resources you want? So how much CPU, how much RAM? For practice purpose, T2.micro enough, but application deployment, so we need to take higher configuration servers. So T2.micro is a free tier, comes under free tier, so will not get charged until below 3 instances. So you can take more than 3 instances, then you will get charged. So T5 means every instance you will get charged. So in this file, I will share with URLs also and installation steps after setting a Kubernetes cluster. Tomorrow onwards, we will work on resources, Kubernetes API resources. So mostly we'll work on more than 10 to 18 services, Kubernetes objects. So more than enough for application deployment. You can easily work on your hands-on working. So I will remove dependency from others.